Hello and welcome to my final project for Instruction 5130, also known as Learning Theories and Instruction. I hope that you enjoy my presentation and I look forward to hearing your feedback. Throughout this presentation, you will notice that there are three main objectives that will be outlined. The first one will be to present the initial lesson plan using the 5E lesson plan model. The second objective would be to apply the learning technologies in the lesson. Those learning technologies will be Google Slides, YouTube, and also PhET simulations. The third objective here would be to identify four learning theories within the lesson in order to improve the quality of the lesson. To better understand what a 5E lesson plan is, I have included this slide in order to break down or to better understand what each single E represents. The first E within the 5E lesson plan is known as the engage phase. This phase or frame part of the lesson plan is used to capture the student's attention. It also serves as the hook. The second phase is the explore phase. This allows the students to investigate the concept through hands-on activities and experiments. The third phase is the explain phase. This phase provides the students with the necessary vocabulary, the concepts, and explanations related to the topic that is being taught. The fourth phase is the elaborate phase. This phase serves as an extension for students' understanding and also encourages them to apply their knowledge in new contexts. The last phase of the 5E lesson plan is the evaluate phase. This is where teachers or just administrators assess the students' understanding and the effectiveness of the lesson. Now, in this slide, you will be able to see my lesson plan. This lesson plan, or at least the lesson objective, is that I will be able to describe thermal equilibrium. Now, if you notice in the title, I also have the word constructivism. That is because in this slide, you will notice that I have an outline of the entire lesson. This helps students to prepare for what they are about to engage in as far as the content. It also gives them a clear understanding of what they will be participating, how they will be participating, and what they should be anticipating. So for the engage phase, the students will watch a video that demonstrates how particles of hot and cold temperatures behave once they begin to interact. In the explore phase, students will explore the relationships between temperature and kinetic energy through the use of PhET simulations. In the third phase, through the explain, students will take notes or get notes with the use of with they will get notes that also contain images. In the elaborate phase, students will conduct a lab, they will collect data, and create a line graph that shows thermal equilibrium. In the last phase, students will be evaluated and assessed over the concept of thermal equilibrium. Now, in this slide, I'm going into further detail as far as the engage. On the left side, you will notice that I have an image that also has a question. Why will both objects reach the same temperature? Now, usually in this case, this would serve as a warm-up question. And this would be primarily based on experience and any kind of background knowledge that the students would have. But instead of using such a generalized question and base it off of what they off their experiences, I chose to rather incorporate a YouTube video that will basically spark their curiosity. This video also um, implements the cognitive theory, which means basically with this video, they are able to have a deeper understanding through visuals. Videos can also stimulate discussion, and they can encourage students to construct their own understanding by connecting new information with prior knowledge. Multimedia learning also emphasizes that well-designed videos can help learners integrate verbal and visual information, and that leads to the deeper understanding. I want to play this video just so you can kind of see what students might end up seeing and how it may spark their curiosity. Although this video did not have any audible elements into it, the visuals spark up curiosity and also the graph within the video gives them a another source of visual representation of how the temperatures are coming from opposite ends and meeting in the middle, thus setting up the schema towards learning thermal equilibrium. During the explore phase, students will be engaging in a PhET lab simulation. So this simulation tool or learning technological tool it involves two different theories. The first theory here is behaviorism because it provides instant feedback on students' actions and it reinforces the correct responses and guides students towards the corrections. Also, this involves the neuroscience of learning because research in neuroscience has actually shown that active participation promotes stronger neural connections, leading to better retention of information. Now, during this, I want to go ahead and click on this link so that you can have a understanding of what these PhET labs really are about. I'm gonna go ahead and click intro, and here you will see a couple different tools. So, as you can see, I have my water, and I'm gonna place my water here. I can also set my thermometer in this water, and I can set this brick over to the other heater. Now, this is a slider where I can either put up the heat or I can make it cold. In this case, I will be turning up the heat on the water. And one thing that I forgot to do is to click the energy symbols here. That way you can see the kinetic energy within each single substance. I will increase the fire or the kinetic energy, and the kinetic energy transfers from the fire into the water, and the temperature is also elevating. I will place a thermometer on the brick, and I will make the brick even colder, losing kinetic energy. As I place the brick in, there is a difference in temperatures right now. If you look at the thermometers, there is a difference in temperatures. Now, what happens when I place this brick inside of the water that is of higher temperature? Both temperatures have reached thermal equilibrium. For the explain phase, this phase mainly incorporates the information processing theory. And how is that? Is because as students are taking notes, they are also provided visuals, right? And so by combining verbal and visual information, it enhances their understanding and their retention. Visuals can create mental images that complement verbal information, and it makes it easier to process and remember information. Lastly, visual notes can actually help organize information into coherent structures or schemas, facilitating easier retrieval and understanding. During the elaborate phase, this is where students would be conducting a lab experiment. And this is also closely related. This is all about thermal equilibrium. So this lab would definitely it would definitely enhance and encourage inquiry-based learning. And this inquiry-based learning would encourage students to ask questions, to conduct investigations, and discover answers through exploration. This is also this lab would also be closely related with the constructivism because it emphasizes that learners construct knowledge through hands-on experiences. So lab experiments allow students to explore concepts actively and derive meaning from their findings. Now, on the right side for this lab in particular, you will see that I have a data table at the top where students will first measure the temperature of ice water and the temperature for hot water. These waters would be in separate beakers. I believe ice water would be in a smaller beaker. Hot water would be on a bigger beaker. So to be more exact, ice water would be inside of a 100 milliliter beaker, while the hot water would be inside of a 400 milliliter beaker. As After recording the initial temperatures, what would happen is that the students would place the ice water, which is in a 100 milliliter beaker, and they would place it inside of the 400 milliliter beaker. Now, just to clarify, both beakers would have 100 milliliters of water inside of each. So after time has passed, students will record how the temperatures of both the hot and ice water are changing. And by the time they reach 10 minutes, they will notice that the temperatures are the same. Before it even reaches 10 minutes, they will notice sometime around 7.5 minutes that the temperatures have equalized, thus concluding that thermal equilibrium is when different temperatures stabilize and become the same temperature. On the bottom picture, you have your graph. This would require a little bit of explanation of independent and dependent variables and how they fall within a graph and how to set up a line graph by plotting your points and then connecting them. Lastly, the last phase of this 5E lesson plan would be the evaluate phase. And in this evaluate phase, this is where we would basically assess students based on their understanding of thermal equilibrium. And this would have to do heavily with behaviorism, this theory. And so with behaviorism, we would use quizzes or tests that provide immediate feedback. This aligns with behaviorist principles of reinforcement and helps students understand their progress and their areas for improvement. And so here I have added a um, a practice question, and if you want to take a second to look at it and kind of come up with an answer, I'll kind of just give it 10 seconds. So if you had enough chance to read through everything and conclude what the answer was, you have to understand that that thermal energy in particular transfers from hot to cold. So in this case, a hot chocolate is the hot, while the air is the cold. So in this case, D would be our answer. Thermal energy moves from the hot chocolate to the air until the final temperature of the chocolate is 10 degrees Celsius. I just want to say thank you very much for taking the time out of your day to watch this video, and I hope that this video gives some clarification about how these theories apply within a 5E lesson plan model. Thank you so much and have a great rest of your day. And again, I look forward to your feedback. Thank you.